In question 6, we begin exploring some different scales that exist out there. There are a number of scales that don't follow the pattern ours does, and by the pattern ours does, I mean we've equally divided in log space. We've equally divided an octave into 12 different pieces. Well, there are a couple of scales out in the Middle East that do the same thing. One of them divides it into 24 equally spaced pieces. The other divides it into 17 equally spaced pieces. All right. And so this question's about the one that has 24 spaces in an octave instead of just 12. And I've given you the beginning of the octave here, which is 257.9 hertz. And I want to know, when you're 10 keys up, what is that? Well, what's the change we need to make in our, let me bring over our notes, right? Okay, what's the change we need to make here to do this, right? So we have 1/12 here when we go up or down one, right? We have, let me pull this out a little bit more, slide over some. We add a 12th to go up. But this is not divided into 12 equal pieces. It's divided into 24 equal pieces, right? So what changes here? This 1/12 becomes 1/24. So we're going to take the log of the frequency. We're going to add the number of 24ths we need to go up that number of keys, and then we're going to go back the other way to get to the frequency. So let's take a look at that real quick. Okay, so what's the log of the frequency? Log F. Log base 2, remember base 2, you just do log of the number comma 2 because the base is an option out there. Default is 10, okay? And now log of our new frequency is just going to be the old frequency plus the number of keys we have to go up times 1/24. Right? And that gets us up to where we need to be, and then get back to Fn. We're just going to take the inverse of the log by raising it to the power, 2 to the power, and we get 344.252 seconds. And that's it for this problem.